Okay, let us discuss this problem. So this is related to solubility of AlOH3. Basically, aluminium hydroxide is basically a solid. So what should be the different condition? What should be the pH so that I can dissolve the AlOH3? So let me read the question. Question asks, at what minimum pH? So basically we have to find the pH. At what pH, and basically this is a minimum pH, 10 to the power minus 3 mole of AlOH3, this is solid, go into the solution, and the volume of solution is 1 liter, so goes into solution, and the volume of solution is basically 1 liter. This is given to you. So what should be the minimum pH so that 10 to the power minus 3 mole of AlOH3 goes into the solution as, so first part says as AlOH4 minus, and the second part says what should be the pH at which it goes into solution as Al3 plus. There are two options, and two things is given to you. KSP is given to you. So KSP for AlOH3, this is given 5 into 10 to the power minus 33. Another equilibrium constant is given to you. So Kf is given to you. For this Kf is for AlOH4 minus, and this value is 1 by 1.3 into 10 to the power 34. So this value given. So let us copy this one. Okay, let me explain the question again and then we'll discuss. So I have, let us say I have AlOH3, a solid of AlOH3, and this is 1 into 10 to the power minus 3 mole. So I have 10 to the power minus 3 mole of AlOH3. So this is solid, and I want to dissolve this AlOH3 into the solution, and this solution has certain pH, and that I want to find what is the pH. What I am doing is I am putting this solid mass into this solution, and my target is to completely dissolve this mass. This is 10 to the power minus 3m, and I want completely to dissolve into the solution, and for that, in one case I want to dissolve in a form of AlOH4 minus, in another case I want to dissolve this in a form of Al3 plus, and I require pH in both cases. So what should be the pH in both cases? So you see what will happen if you want to dissolve AlOH3. One thing is clear: if you want to dissolve this solid mass, you will have Al3 plus 3OH minus. Now let us discuss the part A, that if you want to dissolve into the form of AlOH4 minus, so what will happen? AlOH3 that is initially 10 to the power minus 3 mole, here you will have Al3 plus that will come out to be 10 to the power minus 3 mole, and I want to form AlOH4 minus. So question says I want to dissolve in terms of AlOH4 minus. So what I can do is this Al3 plus can further react with 4OH minus, and it can form AlOH4 minus. Are you getting? And equilibrium for this constant is given. So let us say Ksp is given to you. For this Kf, that is formation constant, is given to you. Now can you solve this question? Can you tell me how are you going to solve this one? That is enough hint is given to you. So just think how will you solve. Let me give a plan. No need to solve. Just give me a plan. How will you solve? Think for 30 seconds. Okay, whatever you are thinking is very correct. You see what will happen. I can add these two equations. So the Al3 plus that is coming in the first step is completely formed a complex because Kf is very high. I want to dissolve all Al3 plus that has come into AlOH whole 4 minus. So I can add these two equations. So if I add these two equations, this goes. I will have AlOH whole thrice. Basically the solid concentration will almost zero because I said all of AlOH whole thrice is dissolved. Very few. This is initially 10 to the power minus 3 mole, so it all has dissolved. So even if you want, you can leave this one. So 4OH minus 3OH minus. So you will have OH minus, and this side you will have AlOH whole 4 minus, and this is Ksp into Kf. Equilibrium constant will be Ksp into Kf. Now I know one thing. Initially I was having this is 10 to the power minus 3 mole, and it has, so, and this is 0 0. This has completely dissolved, so this is 0. Basically there will be very small amount of this solid will remain, because to have this equilibrium there are very small amount of solid may remain in the solution. Whether otherwise, how can I have this equilibrium? I should have very small amount of this solid, very small. Even some completely dissolved, but very small amount of solid will remain. Now this completely dissolved, so I can assume this forms is 10 to the power minus 3 mole, and I have to find concentration of OH minus. This I have to find it out. Are you getting? So now I can write 10 to the power minus 3 divided by OH minus. This is equals to Ksp into Kf, and Ksp is given to you. Are you getting? So you check your value. I can write for you. So this is 5 into 10 to the power minus 33 into 1 by 1.3 into 10 to the power 34. Now I can solve for OH minus. So let us try to solve this equation. So I will have OH minus is basically equals to, so I can take this value that side. So I will have 10 to the power minus 3 into 1.3 divided by 5, and this is 10 minus 33, 10 minus plus 34, so 10. So I will have divided by 10. Are you getting or not? And now I want to find out the value of this using the calculator. So let us say I can use my calculator. So 1.3 divided by 5 into 10 to the power minus 4. So 0.26 into 10 to the power minus 4. So this value comes out to be 0.26 into 10 to the power minus 4. And now I can calculate POH. So that is log of, so POH will be log of minus log of 0.26 into 10 to the power minus 4. So let me check what this value comes out to be. So this value 0.26 into 10 to the power minus 4, and I have to take the log. So log of answer, this comes out to be 4.58. So this is 4.58. So what will be the pH? I have to subtract from 14. So 14 minus 4.58. This is my pH. So I can this plus 14 I can write. So this is 9.41. So this is 9.41. So this is the basically minimum pH at which it can dissolve as AlOH whole 4 minus. Now the B part of the question says, what is the pH at which it can dissolve as Al3 plus? So simply I want to dissolve into Al3 plus. So first equilibrium I will have only AlOH whole thrice. This will dissolve into Al3 plus plus 3OH minus. This means second equilibria is not happening in this case. I want only Al3 plus. I does not want Al3 plus to be complexed. I want Al3 plus. And now if all AlOH whole thrice solid has dissolved, so concentration of Al3 plus will be 10 to the power minus 3. Are you getting? Now I can write 10 to the power minus 3 into OH minus raised to the power 3. This is equals to Ksp, and the Ksp is given to you 5 into 10 to the power minus 33. So you will have OH minus raised to the power 3 is, this goes this side, 5 into 10 to the power minus 30. So you will have OH minus is 5 to the power 1 by 3 into 10 to the power minus 10. So let me see the cubic root of 5. So you will have cubic root of 5. This is 1.7099. So this is 1.7 into 10 to the power minus 10. I can find POH. So take the log of this number. So 1.7 into 10 to the power minus 10 and take the log. This is 9.76. So what will be the pH? So I have to check for pH. pH is basically 14 minus 9.76. So this value, so 4.23. So this is the pH at which all AlOH whole thrice can go into the form of Al3 plus. Are you getting? So let us copy this one. So what this question says, this question is basically using the solubility of AlOH whole thrice. So I am saying AlOH whole thrice can be dissolved with the solution in two forms. Either you can dissolve into Al3 plus. So if you have a pH, that is first part of the question, around, so let me check whether we have 9.41. So this is the minimum pH. So basically in this case this is the minimum pH and this is the maximum pH. So you see I can make a something kind of diagram. So I have a pH 4.23. I have a pH here 9.41. So if my pH is, this is the minimum and this is the maximum. If my pH is greater than 9.41, Al3 plus will dissolve in the form of, this is the 9.41. In this case, if you have excess OH minus 9.41, if you have greater than 9.41, this means you have excess in OH minus. In that case, AlOH whole thrice will basically react with OH minus and it will form AlOH whole 4 minus. Are you getting? And this is again soluble. So if you have excess OH minus, AlOH whole thrice solid will dissolve in the form of AlOH whole 4 minus. Are you getting? If the solution is very basic, in that case it will dissolve in the form of AlOH 4 minus. So this is the minimum pH. So any pH that is greater than 9.41 will dissolve the AlOH whole thrice, that is a bauxite ore, will dissolve in the form of AlOH 4 minus. If the medium is slightly acidic, that is the pH is less than 4.23. So this is the basic pH. And you see this is a acidic pH. If the medium is acidic, and this means this is less than 4.23, so in this case AlOH thrice will basically dissolve in the form of Al3 plus. So what is happening in this case? This OH minus that is coming into the solution, this will react with H plus. So this equilibrium will be pulled towards this side. So I am removing this OH minus by adding H plus because the medium is acidic. So this OH minus can react with H plus that is available in the solution. I am making the solution acidic. So this OH minus will react with H plus and this will come as a form of Al3 plus. This means if my pH is less than 4.23, I am going to dissolve this in the form of Al3 plus. Are you getting? And if the pH is in the midwhile, that is 4.23 to 9.41, you will have both spaces. In solution, you will also have AlOH4 minus, you will also have Al3 plus. So in this case, you will have both species. So this is the best way to dissolve the AlOH whole thrice. Either you keep the pH less than 4.23 or you can keep the pH greater than 9.41. Are you getting? This is used in the bauxite ore extraction of aluminium. We will see in the next classes. So in the extraction of aluminium, aluminium is basically purified. So impure ore of bauxite, AlOH whole thrice, is fast make pure using this concept. So impurity, this AlOH whole thrice will get dissolved into the NaOH solution, and then I again precipitate AlOH whole thrice. I think all of you have copied this one, and then I can go for the next problem.